get let's get this. All right, perfect. Good, good. Alrighty. All right. Whoa, that's a lot of caps. Hello. Hello, Adam. How are you? I hope you're doing pretty well. Yeah. I'm doing pretty good, my friend. Doing pretty good. A nice fresh week. Ready to go. How was your weekend? Wonder how that affects things. Oh wow. Okay. Your weekend was cool. Your school is closed. Oh no. That stinks. I mean, it's nice to get off of school, but yeah, you gotta get stuff done by yourself. Sometimes that can be tough. I can totally see where you're coming from there. How you been able to do the online learning then? Has it been a little, has it been easy? Has it been tough? What do you think? Yeah, that's fair. As long as you're picking up the material, that's cool. That makes it easy for you then. Nothing wrong with that. Okay, that's fine. All right. Okay. Yeah, yeah, that's true. Sometimes face to face is the best, so we can address some things like, because it is tough to contact us necessarily, uh, a lot. So especially when you have that many people on at the same time, it could be a little hard. You're just more productive face to face when you're at least in a school setting. You can be. But we gotta work with what we gotta work with. As long as Mr. the COVID is around. And that's just how it's gonna be for a little while, unfortunately. But hey, gotta make the best of things. That's what we do. Yeah. Hopefully you learned a little bit off of this stream, at the very least. Yeah, this stream's supposed to be pretty, of course, educational, as it says, but, hopefully a little fun too. So, just super chill, super relaxed. You can have a nice time. All right, we got a few more people here in the chat, so come on in and say hello. That's fine. Be starting here in a couple of minutes or so. All right. Looks like we got a few people here. All right, good, good. Hello, everyone, again. Hello, hello, hello. Good morning. All right. Good morning, everybody. We're going to get started in just 1 minute, and then we'll get going. I'm going to start with some new material, but some announcements, some new material, and stuff like that. All right. Almost there. All right. Got this. Got this. Better check this. I turn that off. At least I hope so. Yes, no, maybe, sure. I did, yeah. All right. Okay. Good beans. All right. Okay. Good stuff. Okay. So let's go ahead and get started. There we go. All right. Okay, let's get started today. Welcome back to Tuesday. Hopefully, you're having a nice weekend. All right. So I do have an announcement here for everybody in Math 90. All right. So today, again, we in the makeup class last time, we actually finished up the last part there of chapter 3. Again, that test is due next week. So I think I made that test due on the 19th. Um, I, yeah, I did. All right, so the test is going to be due next Monday, and that's been set up and ready to go. So you can go ahead and get started with that. Again, it'll be the same process as it was from before. So all you need to do is, again, submit the work for the chapters 2 and 3 test, all right, on D2L. So just submit your work there. And again, I've posted all the grades so far for the first exam and all your assignments from the first chapter. Remember, chapters 2 and 3 will also be due next week as well, so all the homework will be due then as well. So please set aside some time. There's also, once again, the practice test, which is worth some bonus points. So be a good idea to get a little practice in and get that squared away. All right. Um, really quick here, are there any questions about the test there that you guys would like to know? Um, any questions at all? There's really not much of a difference. I think I put like I put some amount of questions on there. I think I put like 35 or 40 questions, something like that. So, but are there any questions about the test from last time that you guys would like to know real quick? I gave you a time limit. There's going to be two tries. Again, time limit is pretty long. It's like 6 hours or something like that per try. So just let me know. Again, just say no in the chat, or again, if you do have a question, please go ahead and type that out in the chat so I can go ahead and acknowledge it. No? Okay. No? All right, so make sure you get that test done. That'll be great. Everything's clear. Excelente. That's exactly what I'm hoping for. All right. In any case, okay, so let's go ahead and move on to the new material here for today. So today we're going to be starting a new chapter here, chapter 4. All right, so we talked about fractions in the last two chapters, but now we're going to switch gears here to talking about decimals here in chapter 4. All right, so today we're going to be talking about reading and writing decimal numbers. All right. So let's go ahead and talk about the basics here of a decimal number, and then we'll kind of look at some examples here about how to, say, convert from fractions to decimals, and also decimals into fractions. Now, for us to go ahead and at least start understanding this, let's see here. Okay. So there's one thing I kind of want to talk about here really fast. So, there you go. Okay. So the one thing I do want to talk about here is just decimals. All right, so let's talk about the basics of decimals and placeholders. So this is going to be pretty important for the couple of sections we're going to cover here today. Maybe this section 4.1 and possibly some of 4.2. And so what we want to talk about is, well, okay, how would you look at the basics of decimals? They represent, of course, a portion of a whole number. That's basically what a decimal will represent. So decimal is a representation of a part of a whole number. So as we like to say, a third, so aka representation part of a whole number, aka a fraction. Okay, so you say 1/3, of course, that has a decimal equivalent to it. But the question is that how do we know to go backwards and forwards? What's the key to really kind of put all that together when it comes to decimals? So let's talk about that. So what we're going to talk about is we're going to talk about placeholders, okay? Placeholders are going to be the very important key when it comes to understanding how decimals work. Okay, so for this one here, I'm going to bust out the paint tool for this one. Um, so I can show off how placeholders actually work. Okay, so we have a decimal. Let's say we'll put 0 here as like our whole number, but let's say we have, I'm going to separate these numbers out appropriately. So 1, 2, 3, 4, 5, 6. Okay. Okay. So let's say this would be the decimal here, 0.12345 Now I went ahead and just separated those numbers out because what we're going to do here with these particular numbers is identify the placeholder of each of these separate individual numbers. What do they represent? Because if we understand what they represent, then you'll see how we can take that understanding of that representation and then bringing it back into like saying talking about fractions and how that's going to work. And you'll see how those correlate with each other at the end of the day. So let's take a good look here at this 1. So this is going to be, we're going to look at all the numbers here to the right of the decimal point. So when we started talking about whole numbers, we had the 1s, we had the 10s, we had the 100s, and so on and so forth. Well, we're going to do the same thing here. Now, in this case, though, there is one key difference, and that is the very first number here. So the very first number here to the right of the decimal point, this 1 here, is what we call the tenths. So this 0.1 here is the tenths spot. So it's not the ones spot. The one spot would be to like, 1, 2, 3, 4, 5, but on the left of the decimal, but this is the tenth spot. So we start off with tenths to start with. So when somebody says 1 decimal place, really they're talking about tenths, all right? So all right. So some questions on the homework will ask you to say, put the answer in tenths, okay? Then that's what they're talking about there, 1 decimal place, okay? That's essentially what they mean. Okay. Now 2, if we go from tenths, we go, say, again, if we go from, we go ones and then tens and then hundreds. So then after tenths will be the next one up here. That'll be hundredths. So we got hundredths. And we could do the next one here. We could do 3 here. This 3 here will be the thousandths. So the thousandths place will be right here. Okay, that'll be 3. 4 here. So what comes after thousandths is 10 thousandths. All right. Then we have 5. Let's put that in green. Okay. So 5 is going to be 100 thousandths. And then finally, we have 6. So 6 here can be represented as millionths. Now you could keep going here if you want. You could have 7 be 10 millionths and 8 be next decimal place over will be 100 millionths. So you could go on forever with the amount of decimal places. All right, but these are the most common ones that we see most of the time. So 2 decimal places represents a hundredths, 3 decimal places a thousandths, 4 decimal places is going to be 10 thousandths, 5 decimal places, 100 thousandths, 6 decimal places will be millionths, and so on and so forth. Okay, now we're going to use this template here to start understanding how we can sort of relate fractions that we talked about the past 2 chapters and this part here when it comes to decimals here together. So let's take a look here at the book, all right, and we're going to go ahead and use this little chart dude to help ourselves out. So let's do that. go. Okay. I'm going to shrink this down a bit so we can see that. There we go. All right. Okay. So let's take a good look here at this first part. All right. And you'll see exactly how I'm going to be putting this together here. So it says, let's look at this example here, this first example on this page 140. It says, write the portion of each square that is shaded as a fraction, as a decimal, and in words. Okay, so here we have 3 over 10. All right, so we have 3 over 10. Now we want to write that as a decimal, 3 over 10. Okay, so let me bring that up here. Okay. So I'm going to write this over here. Okay, so let me write this as a fraction here, 3 over 10. Now, another way to say 3 over 10 is 3/10. All right, so this sounded out as a word. So as another fraction, another way to say this, so to say sounded out, would be 3/10. Okay, that's another way of saying the same exact fraction as you can see here. Now, if we're going to relate this, take a look at what we have here. Well, didn't we call this spot, this very first decimal place, didn't we call this the tenths place? Well, that's exactly how we're going to write this decimal. We say, okay, we have 3/10. So that's 1/10 in there. Well, this 0.3 would be 3/10. That's how we would say that all together. Okay. So let's try another one and let's see how that goes. So let's go with another example here. That's one of the basics ones I want to kind of talk about here. Let's talk about this. Okay. How about this one? Let's talk about, yeah, let's do these. So how about 9 over 100? So let's talk about that. Okay. So 9 over 100, all right? So how would you say 9? Okay, first of all, let's say it in words. What would 9 over 100 be in words? So what would 9 over 100 be in words? So if you notice that the first one here says 3/10, so 9/100. Okay, good. That's right. 9/100 is correct. So we're going to put this in words here. We'll put 9/100. All right. All right. So if that's 9/100, another way to say this, 9/100, or 9 over 100, how can we write 9 over 100 as a decimal? How can we write that as a decimal? Okay, very good. That's right. So notice that the 100 spot here is in the second spot, and we want 9 of these hundreds. So we have 0.09 would be correct. Okay, so that would represent the fraction. The fraction of 9 over 100 represents 0.09. All right, let's look at another one. Okay, let's try. All right, let's try. Excuse me. 832 over 1,000. So let's try that one. So the question is, how can we write 832 over 1,000? How can we do that? We want to write that as a decimal. How can we write 832 over 1,000? That's as words, so that's correct. 832 thousandths is how we say it as a word. Now, okay, so that's right. That's right as words. Now, how do we write it as a decimal? We have 832 thousandths. Well, that's close. Not quite there. Not quite there. Think of how we say this, right? We say 832 thousandths. So that part, like I said, totally agree with 100%. All right, so that part 100% correct. But which place in this picture that we have here, where's the thousandths place? Is it in the first spot, second spot, third spot, fourth spot, fifth spot, sixth spot, third spot? Okay? So the thousandths place is in the third spot there. So that's effectively where we're going to stop. All right? So 832 thousandths, that could be re-represented as, so 2 is basically, it's the third spot there, the third decimal place. So we're going to have 8, 3, and 2. Because the 2, we would say 832, and that last spot there would be the thousandths place. So that's why, yeah, the last number should be at the end. That is correct. So let's add that as a note. Okay. Note here. Last number should be at the proper placeholder. Okay. All right. So this is kind of one of those notes there that's important. So last number should be at the proper placeholder, and then that's fine. Okay. All right. So this is basically to find, this is basically from fraction to decimal. So, all right. There we go. Okay. Are there any questions about that before we move forward? Any questions, anybody? No? Okay. All right. Oh, yes, I forgot to mention here. Apologies. I do want to apologize about last week. Sorry that my computer went totally kaputski. I want to thank the people who came out last week. But I do apologize that I was not here last Thursday for the last class. Yeah, my computer just absolutely went out on me. So, um, yeah, it was kind of unfortunate, but it worked out okay. So, just wanted to let you know about that. I had to get those repairs, and I did get the repairs. It's just, oof, it was pretty rough. So, All right. All right. Let's go ahead and now talk about decimal to fraction. So what if we're given a decimal here and we want to convert that decimal into fractions? Okay, let's talk about that and how we can do that. So let's look at our first example here. Let's look at 0.7. Okay, so again, took 0.7. Now, the important part here regarding 0.7, or any decimal for that matter, now typically we call it 0.7, but uh, another way, we want to sound it out in words once again. Okay, so let's take note of the placeholder where 7 is located. So the key here is to, so let's talk about the key here. So the key here is to take note of the placeholder where the last number is located. Okay, so what exactly does this mean? Well, let's look at our particular guy here. So with 0.7 here, if you see there, 7, the last or only number we see in this problem, is in the 10th spot here, according to our placeholder chart. Right, so that's why we are going to read this as exactly correct there, Adam. So they're going to read that as 7/10. So first I look at the placeholder about where that last number is located. Then I can read the whole number and then take that placeholder at the end. Hence why this is 7/10. Now if we read it as 7/10, we could just write the fraction exactly as it sounds. So then the final answer for this is going to be the fraction of 7/10. All right, and that's it for that problem right there. Okay, so that's how we can convert it back into a fraction, is just we just read it, put it in words, and then convert it back into a fraction once we're good and ready. Let's look at another example here. All right, this one here, I'll ramp up the difficulty just a bit. How about, we'll go with this. So we'll go with 0.34. So can anyone tell me here, how can we read this particular number in words? Ooh, excuse me. How could we read that in words? Okay, so right, the 4 is in the hundredth spot. So notice it's two places away. That is in the hundredth spot, as you can see here. So this is going to be 34 hundredths. And so, hundredths, there we go. And so basically, we're going to go ahead and rewrite the fraction. What will the fraction look like? What will the fraction look like? So 34 hundredths, how can we see the fraction there? 34 over 100, that's right. Okay, so 34 hundredths. Okay, so 34 on the top and 100 on the bottom for hundredths. Okay, All right, so that'll be our answer for this problem. Okay, good. Okay, now I'm going to have you guys try this one. This one's a bit tricky, but let's try it out and see what you guys get. All right. Okay, so point 0005. Okay, and I want you to write that as a fraction. So how could we write this particular decimal as a fraction? Hello, you can do it. Yes, you can. Absolutely. Check that. It's up to you, I9. Okay. So let's read this together here. So we have tenths, hundredths, thousandths, and 10,000ths. So this would be 5 10,000ths. That's correct. Or again here, this is going to be, let's go here, 5 over 10,000. There you go. And we saw where the last placeholder was. That was going to be 10,000ths. And there we go. We got it. Okay. There we go. Nice. Okay. Any questions about that? Ooh. Questions, anybody? No? Okay. All right. If you do have questions, again, feel free to go ahead and ask, okay, at any time. All right? Okay. Let's move on here to the next part. Okay. So we talked about the placeholders. I wanted to talk about the placeholders first. They said they kind of mentioned it later, but I'm like, yeah, that's kind of pointless. I was not very super duper happy that they did it afterwards. So it makes it just a lot easier to do the concept as is. All right. And we kind of already read it in words, so that's fine. Okay. So this talks about how to identify the place value of each digit. So for example here, they talk about 178.36. Okay, so if you were to do something like that here, let's talk about that here real quick. Not a super big deal. But if you see a problem like that, you're like, okay, what is it asking? Oh, okay. If the numerator will be larger than the denominator, this number will be bigger than 1. That is correct. Yes. So you could actually reflect that, Adam, as a mixed number, or you could just put it as an improper fraction. Either way, yeah, it'll just be bigger than 1. That's right. So we can easily put like this decimal number here, for example, 178.36. So if you identify the place value of each digit, well, then you have the 1. Basically, you have 1 in the hundreds, right? You have the 7 in the 10 spot. You have the 8 in the 1 spot. We have 3 in the 10th spot. And we have 6 in the 100th spot. So if we want to break down that number, that's basically how it goes. 1 for hundreds, 7 for tens, 8 for ones, 3 for tenths, and 6 for hundredths. Now, in this case here, yeah, so it'd be like 178 with, again, a decimal attached to it. Again, clearly bigger than 1. So if I were to put this here as a fraction, for example, I could put it as this fraction here, 17836 over 100. Because the 6 is in the hundredth spot, so I could re-represent it as 17,836 over 100, so clearly above 1. All right. Are mixed numbers just two fractions multiplied by each other where the denominator of the first one is equal to 1? No. Mixed numbers are, again, you have a whole number component and a fractional component. So mixed numbers here look like this, like 5 and 3/4. So if you do higher level math, you don't really run into mixed numbers all that much. But if you're doing like basic calculations like and stuff like carpentry and stuff like that, yeah, you of course use this quite often. So um, 5 and 3/4 would be an example of a mixed number, and then we could convert, as we talked about here, but it says okay, we can convert these mixed numbers into, say, improper fractions. That's certainly plausible too. Okay. So we talked about how to read this into words. I'm actually going to throw, should I throw one more? No, I already did that one. Okay. Now, let's read decimals here because I want to read each of these decimals in words, how you would read this. So we're going to go ahead and give it one more shot here. So how would we read, let's go with letter D here, as it says 11.1805. 1085, sorry. Oh, what the heck? How could I read that as a decimal number? So I'll give you the first part here. So we're going to say 11, 11 and, so that's basically how we have to read this. So 16.9 is 16 and 9/10. So here we have 11.1085. We have 11 and something. Want to take a look at the placeholder there, by the way. So how could we read the rest of that? 11 and what? Okay, good. So here we have 1085. But if you see here, this 5 right here is the important linchpin, right? This 5 is located in the 10,000th spot, i.e. 4 decimal places. So this is 1085 10,000ths would be another way of actually doing this out. So we'd have 11 and 1,000, yeah, sure, whatever. 1,085 10,000ths is how we would write that in words, just like so. Okay. So that's how we kind of can put it together here is like, okay, we got the 11 part here, the stuff to the left of the decimal place, And then the stuff to the right of the decimal place will be, you know, 1085 ten thousandths is how we read that as actual words. All right. Now, now we have a pretty good idea about that. Let's put it together in one. It's sorry, math is a different language altogether. So this is what we have to be stuck with. Yeah. All right. So we have. Let's go ahead and put this here. So let's put this here. We got. Okay. So can anybody tell me how we could read this number here? So 412.987. How could we say that in words? 412 and 987 thousandths. Very good, Ola. That is correct. So we take the first part there, right? All right. 412 and 987. And then since the 7 is in the thousandth spot, that's what we'll put at the very end. There we go. Got it. Okay, nice. Okay, any questions about that? Hopefully that wasn't too bad. You're like, yeah, yeah, yeah. All right. All right. Now, the last part here is something we've already talked about, which is putting the decimal as a fraction. However, we're going to take it one step further. All right. So we're going to take a decimal to fraction, but with one caveat, and we're going to reduce the fraction at the end. So what does this mean? This basically means this. If I have, say, here's a good example. A good example is if I have, say, 0.16, okay? Now, 0.16 we can rewrite into a fraction that's going to be 16 hundredths. Okay, so we can literally write it as a fraction of 16 over 100. Yeah. But with 16 over 100, you can reduce this down, okay? So one of the things that we can do with 16 over 100 is reduce it down into its more basic form. So what we want to do is, let's say we want to divide here. We divide each one by 4. You could do 2. You could divide by 2 as well. Again, we divide by 4 on the numerator and denominator. So let's see what we get. And here we get 16 divided by 4, which is going to be 4. And then 100 divided by 4, which is 25. And so, as you can see here that, yeah, we're just going to take that one extra step, and we'll have that equal to 4/25. That's correct. So that's all we're doing here is taking that extra step if we have the option to do so. It won't always be the case where we have that option, but if we can, that's fine. Now this also reflects mixed numbers as well. So again, if we had, say, 1.16, all right? So let's say we have our example here of 1.16. Well, this is the same exact thing. It's just a 1 on the outside, so 1 and 4/25. So the way we approach it is no different than how we did the last problem. The 1 is just separated out from the actual decimal part, and that's all we have to do for that. So let's look at another example, and let's see how this works. Okay. Okay, so let's write 18.105. So let's go with that. 18.105. So we have 18.105, and we want to convert that into a mixed number. So the first part here is going to be just 18, 18 with some fraction, okay? So you could take that to the bank and be like, okay, it's 18 and some fraction next to it. So technically you don't really have to worry about the number in front because it's always going to be in front if we're converting it into a mixed number anyway. The part that we have to be concerned about is the 0.105 part. That's the part that we actually have to focus on. So if we write 0.105 as a fraction, how can we do that? How can we rewrite the decimal part, the 0.105, as a fraction? How do we write 1.105 as a fraction? Okay, good. That's correct. Excellent. So 105 over 1,000 is correct. All right, nice job. Now, we have to be able to reduce this down, okay? So reducing this down is going to be of vital importance. So let's see if we can do that. So what does this reduce down to? What can we divide by in the numerator and denominator? What's a common factor? We could divide by 5. That's correct. Okay. So if we divide each one by 5, all right, let's see what we get. So on the top here, we get 105 divided by 5. That will be 21 if you do that out. And 1,000 divided by 5 will be 200. So that's going to be our other part of our fraction here. So 18 and 21/200ths will be our answer. Unfortunately, yeah, we can't reduce that down further. So you could try. 3 doesn't go into 200, neither does 7. So that's all you're stuck with there. 21 doesn't either. So we'll keep that 18 here? Yes, because the 18 was part of the original problem. That was right here. So basically the 18 is always just going to, whatever number's on the outside to the left of the decimal place will always go on the outside of the mixed number. Okay. All right. Um, any other questions before we move on? I hope that made a little bit of sense. Actually, I could have you guys try one. So let's have you guys try one, actually. I think that's fine. All right. So try this next one here. This one here. Actually, no, that one's actually really hard. Yeah, three. Let's try something little bit easier, so it's not too much on the brain. Point about 3.05. Let's go 3.05. Okay, something nice and simple, but still 3.05. So tell me what that is as a mixed number. Yeah, but you got to reduce it down there, Adam. Don't forget. So reduce that fraction down. Okay, that's correct. So here we have 5 over 100. That's right. Okay, so 5 over 100 is correct. But remember that you have to reduce it down. So you want to divide by 5 on the numerator and denominator here. So so again, if it's reducible, then you got to go ahead and reduce it, right? Okay, good. Yeah, always think about if you can reduce it down at the end there. So that way you get the most accurate answer possible. Okay. All right. Any questions about this first section here? Okay. All right. Okay. Let's talk about the next section then. All right. So the next section here is going to be section 4.2. Okay. Now, let's talk about section 4.2, which is rounding decimal numbers. So there is a process into rounding decimal numbers here. And if you remember what we did way back when we first started to round whole numbers, well, we're going to do pretty much a very similar thing here in this case. All right, so we're going to go ahead and see what we need to round and then the number that we're going to use to check. So we're going to use that same technique of circling and underlining so we can properly round here in this particular case. So here we're going to just talk about the steps, okay? Now they put some steps up here, but I'm going to keep it a little bit more, a little bit easier than maybe kind of doing all that stuff out. So let's look at that first example there. It says to take 14.3965 to 39652. So we're going to take 14.39652 and we're going to round to the nearest thousandths. Okay. All right. So we're going to talk about the steps on how to find this particular answer here, and we're going to break it one step at a time. Okay. All right. All right. So let's go ahead and do this. So just note these placeholders that I'm about to erase. Okay. That's important for this. Okay. Step one is to basically find the number in the placeholder you want to round to, and circle it, or actually underline it. Okay. Actually, no, circle it. We'll say circle it. Make this a bit easier. Yeah, I'll go with the circle there. All right. So we'll focus on the number in the thousandths. Yes. So if we take a look here, the number in the thousandths. All right. So we have 3, 9, 6, 5, and 2. Which number here is in the thousandth spot? This is going to be step one. So we're just going to focus on the number in the thousandth spot. So which one of these 5 numbers that you see here is in the thousandth spot? 6. That is correct, Ola. Right. So we're going to circle the 6 here, just like so. So this is step one. This is all we've effectively done. Okay, so that's step one. All right, next. Let's talk about the next one here. And there's the next step. Right. But what we want to do here, Adam, is just to be able to visualize. One of the things that we don't want to do is just guess. Especially rounding can be a bit of a pain. There is a little bit of an exception that we kind of have to throw into the fray. So we have to be a little bit careful about the rounding rule about how it works in some circumstances. So I'm going to point that out as well. So in this case here, what we want to do next is we want to go ahead and underline the number to the right of the number you circled in step one. Okay, so we're going to go ahead and underline that number, which in this case happens to be 5. Oh, okay, so we're just going to underline that 5 just like so. So we circled the 6, and we underlined the 5. Now, so that's step 2. So this is um, so this is step 1 up here. This is step 2 down there. Okay. Okay. Now, let's move to step 3, the actual rounding part. Step 3. Step 3. If the underlying number is 5 to 9, then round the circled number up by 1. Okay. If the underlying number is from 0 to 4, then keep the circled number the same. Okay. So if the underlying number is from 5 to 9, we're going to round up by 1. And if the underlying number is from 0 to 4, we're going to keep that circled number the same. Okay. Now there is a fourth step here, and this is one thing that I do want you to be careful about. Once you round, then all numbers to the right of the circled number should be zeros. Okay, so one of the things to take to the bank here is that the biggest mystery is why is 5 on the upside? Well, because 5 is on the 50-50 end. That's why. That's why 5 is on the upside. 5 is on the positive 50-50 end, which seems weird, but when you think about it, it kind of makes sense from the perspective of 0 to 4 and 5 to 9. Oh. It's just a different perspective, that's all. Just a different perspective you have to look at. It's not always going to be like, straightforward, but that one is the reason why. Yeah, if you consider 0 to 4 to be the low side, it's like rolling a 100-sided die. All right? 0 to 40, if you started at 0, 0 to 49 would be your low side, 50 to 99 would be your high side. Yeah. All right. So in this particular case here, step 3, let's go to step 3. Okay, so step 3 here, again, as you can see, we have a 5 next to the 6. So we're going to raise that 6 up to a 7. So we're going to get 14.397. And then the other two numbers here are going to be zeros. So we just want to be sure, again, if you want to plug in your zeros, that's fine. Okay, you can put in zeros here, or you could just leave them off whichever way you want. It doesn't really matter. But this is what we have here in this instance. Okay. Any questions about that so far? Okay. Now, there is some exceptions to this rule, so let's talk about some of the things that you may encounter when it comes to rounding. So I'm going to put up another example here, and you'll see this kind of a thing that we may have to adjust with. So let's say I have 13 point, let's go with 7, 8, 9, 9. So let's go with, let's say I have this, and I want to round, let's say, to this decimal place, so the thousandths again. Okay, so let's take a look at what happens here. In this case, clearly this is going to be rounded up by 1, okay? So you're like saying, well, wait a second here. You're rounding this up by 1, but if I add 1 to this, I technically get 10. So if you go up by 1, you go a plus 1, then technically you get 10. So which means is that this 10, this is going to be added into the 8 over here. So in reality, you have 13.7900. So basically, I'm saying this is if you have, let's put this note here so it makes a lot more sense than maybe with a bunch of arrows. Note, if you have if you have two nines, or if you have a 9 that you are rounding up, then add 1 to the number left of that 9, and change all the other numbers to the right to zeros. Repeat if you have other 9s left of the initial. So repeat if you have other 9s to the left of the initial 9. What do I mean by that? Well, let me go ahead and point this out here. So if I have, say, 13.8956 whatever, and let's say, oh, actually, that's a pretty poor example. Let's try this again. Let's say I have 9, let's say 0, oh, man, gosh, I'm try my best. Let's try 0999. Okay, so let's 998 or whatever. So if I were to go with this 9 here, I would round up by 1. So I would make this a 0. I make this a 0. So this goes up to so this goes up to 10. This goes up to a 0. Now this goes up to a 0. And then now this goes up to a 1. So because we rounded up there. So technically what we have is 13.1 is what we get there in that particular instance. So that's what can happen if you have a bunch of 9s. You just keep going to the left and you're like, okay, I got to round that up to 0. Okay, I got to round that up to 0. Okay, I got to put that up by 1. And so that's basically what happens in that particular instance. So there's a couple of exceptions that I guess I wanted to point out there and be like, okay, it's there, it's just, all right, it is what it is. This doesn't happen super often, but it can. So I don't say really often, but it's not a once in a blue moon effect either. Okay, are there any questions about that? We're going to do some more examples, of course, but any examples about the steps here at the very least? All right, let's look at some more examples then, and let's see how this works out. Well, if you're rounding it to the nearest whole number, sure. It depends where you're rounding it to. So, yeah, if you have like 13.9 and asks you to round to the nearest whole number, and you say, okay, round up to 14. Yeah. Then that'd be 14, yeah. But it also depends on where you're rounding it to. So, that's where you kind of have to be a little bit careful. Note in the instructions where you're rounding it to. That's very important. Okay. So let's take a look at some couple of examples here. So let's look at this first one here. We're going to round, what do they want us to round to? Round to the place indicated, so the nearest 10th. Okay. All right, so they want us to round to the nearest, what, 10th? Okay, let's do that first. Sounds fine to me. All right, so 57.976, we're going to round to the nearest 10th. Okay, so looking at this number here, what number is in the 10th spot? What number is in the 10th spot? All right, 9. Perfect. Very good. That's right. So we're going to circle the 9 here. Nice. Okay, so what number should we underline here? Okay, the 7. Okay, so now that we've underlined the 7 here, should we round up or keep it the same? Okay, that's right. We're going to round up. Now, remember, we're going to round this up. This is 9. 9 is going to round up to 0. Okay? But then that means that this 7 needs to round up to 8. Remember that we're going to take that last exception of the rule there, and we're going to round that 7 up to 8. Right. So what we get here is we get 58.0 as our answer, or just plain 58. Are there any questions about that one? So hopefully everybody saw what happened there. We used the 9 rule for that one. Let's try another one then. Okay, so here we have 11.0299. We want it to go to the nearest hundredth. Okay, I know it says nearest thousandth on there, but I decided on nearest hundredth for this one. So which number is in the hundredth spot? What number do we have to circle? 2. That's right. So let's go ahead and circle 2. And what number are we going to underline? The 9, okay? Good. That's the number directly to the right of that. Okay. Now the question is, do we round up or do we keep it the same? Do we round up or do we keep it the same? Okay. So because it is 9, again, between 5 and 9, then essentially 2 here, we're going to round it up to 3. Separate this out here. Okay. So what we'll get is we'll get 11.03. The other two numbers become zeros, and there we go. That's our final result there. All right, here's another one. How much will you pay in each shopping situation? Round each money to the nearest cent. All right, so we have 2.4238. We want to round to the nearest cent. So round to the nearest cent. If we add all the zeros, would it be wrong? You mean at the end there, Hannah? Like if we put 0.300 like this? If that's what you're talking about there? Oh, okay. No, you would not be wrong. No, it would still be the same. It's the same expression at the end of the day. The reason why I say put zeros at the end, so that way you don't forget, is like, hey, instead of just like cutting it off necessarily, you could say, oh, this is the same representation if we put a bunch of zeros at the end. So that way you know you don't have to look at any more numbers either. So that's true, but again, it's a good way to remember that I don't need to look at the last set of zeros there or last set of numbers. So you're not confusing yourself at the end of the day. So again, it's a way for checks and balances to be made, because one of the most confusing things is that people think that they have to use like every number in the problem, but that's not necessarily true. And if we remove them beforehand, then they're not a problem anymore once we reach our final result. So we're trying to cut that off at the pass, essentially. That's the difference there. There's trying to just take techniques in order to reduce the amount of confusion in a lot of these problems can have. So remember, no guessing, just doing. That's what we want to do. We don't want to have to guess like a bunch. Okay, so we want to round to the nearest cent. What does round to the nearest cent mean? So 1 cent is a hundredth of a dollar. That's correct. So how many decimal places would that be? So it's a hundredths, right? So what number would be in the hundredth spot in this problem then? That's correct. All right, the 2. That's right. Okay. So just kind of stating that there. Okay. And so if we round this, again, if we're taking a look here at this one, all we're doing here is simply going ahead, taking this 2, circling that, underlining the 3. And as you see there, since this is between 0 and 4, we're going to keep that the same. So we're going to round this to $2.42 straight up as is. And that'll be our final answer for that. Okay, that's fine. Okay, are there any questions about rounding here? We may start with a little rounding at the very. We may start with a little rounding here at the beginning for next time, but yeah, we're in good shape. So we may just do one example and then move on. Any questions? Okay, right. So if there are no questions, that is okay. We're out of time actually. So time really flew by today. So really, really good. Okay, so again, you do have a test to do. Again, chapters 2 and 3. So just don't forget to do those by next Monday. And then, yeah, don't forget to submit your work on D2L as well. All right, so we are good to go. So that'll take care of it for today, everybody. Thank you very much for coming out to the stream here once again. I will be back in a couple of days. All right. Um, to do the next couple sections, which is adding and subtracting of decimals and probably multiplying and dividing as well. All right, so we're going to spend some time doing that. But in the meantime, I want to thank you all again for coming on out. If you are here for the 11 o'clock class, I will be back in 10 minutes, okay? In 10 minutes. All right? So, everybody here who's for the 9:30 class, thanks again, and I will see you all later, okay? Have yourself a great one, everybody, and take care. I'll see you in 10 minutes if you're for the 11 o'clock class, though. Thank you very much. Have a great one, everybody. All right. We'll see you later. All right.